Hi everyone, my name is Xiaowen. I'm the PM for Anthos Multi-Cloud, and I'm really glad to have the opportunity to be here virtually with all of you today to talk about modernizing and managing your apps with Anthos. A pain point that we consistently hear from customers is that they have a lot of legacy apps running on older infrastructure, using older frameworks, and that have become hard to maintain. Customers are looking for a platform to help modernize these older apps, as well as leverage the modern best practices for their new apps. And this is where Anthos comes in. Anthos is an application modernization platform that helps teams move faster and at scale. With Anthos, you can modernize your apps in place, on-prem or in the cloud. You can automate policy and security at scale for all of your apps, and you get a consistent operational experience across all of your deployments. Anthos is designed to be deployed wherever you deploy your apps. You can use it to build an application platform on top that abstracts away many platform-specific details. The vast majority of enterprises today are operating in a hybrid or multi-cloud environment. A lot of customers want the flexibility to choose different environments for different apps while reducing operational overhead. Some workloads must run on-prem due to security and regulatory reasons. Other workloads have been designed to take advantage of certain best-of-breed solutions from specific cloud providers. And beyond that, many customers want their apps to be able to run on any cloud and sometimes be able to simultaneously run on multiple clouds. Many customers want to be able to burst from on-prem to the cloud or failover from one cloud provider to another, or load balance between multiple clouds. And do all of this in order to achieve resiliency goals, cost savings, and reduce vendor lock-in. To enable these hybrid multi-cloud use cases, Anthos is highly optimized for many deployment environments with a consistent operational experience that takes all of them into account. On-prem, we support VMs running on VMware vSphere, with bare metal support coming soon. We interoperate with a large number of storage and networking providers so that the platform can easily integrate with your existing infrastructure. In the cloud, we integrate with cloud-specific services, such as load balancers, private virtual private clouds, and identity and access management. GCP and AWS are currently fully supported, with Azure support coming soon. And at the mobile edge, we're partnering with telecommunications companies and providing a deployment option that's optimized for the small footprint, large fleet size, and the unique networking requirements of that environment. Now, on top of this distributed infrastructure, Anthos provides the tooling and the best practices built in for all the different members of your team. For infrastructure operators, we provide a unified experience for managing your Kubernetes clusters in your environments, along with the configuration policies required to meet your enterprise security and compliance needs. For service operators, we provide a way to gain visibility and control of your services, including traffic management, authentication authorization, monitoring, and alerting. And for developers, we provide ways to easily deploy and run modern serverless workloads without needing to learn about the underlying infrastructure. All of these components are built on open source foundations, much of which was first developed at Google. With Anthos, we put the Lego pieces together to give you a managed and supported experience for your infrastructure so that you can focus on your unique business logic. So let me show you in a demo a bit more about how all of this works. We'll first look at some details of the individual clusters, and then we'll take a look at the unified management experience provided on top. Here, I have created 4 Anthos clusters. The first one is a GKE cluster on AWS. The second one is an EKS cluster, also on AWS. And the bottom 2 are GKE clusters on GCP. Anthos on AWS just reached GA status recently, and we've heard of a lot of customer interest here. So let's take a quick look at how GKE integrates with the AWS environment. Under the hood, the cluster is running as a number of EC2 VMs in AWS. The cluster control plane consists of 3 VMs that can be deployed in a highly available fashion, as we have it here, across 3 availability zones in the same region. The other 3 VMs here belong to a single node pool deployed in a single availability zone. You can also add in additional node pools and put them in different availability zones in that same region. Note here that none of these nodes have public IP addresses. For security reasons, most of our customers prefer that the clusters are available only on an internal network and can only be accessed via a VPN or a similar mechanism. A lot of customers have well-established AWS VPCs that have been through rigorous security reviews. So GKE is designed to be able to install into the customer's own VPC and stay within the established boundaries. From a management perspective, we're starting with a foundation that most customers are already familiar with. Just like the Kubernetes-based apps that you deploy and manage, GKE clusters and other Anthos resources can also be defined declaratively in a YAML file, which can be stored in source control. And they can follow similar processes like code reviews and have manual approvals before deployment. Additionally, you can enforce policies on it using the same tools that you use to enforce policies on apps defined in YAML files. For example, here is the YAML file I used to define the GKE cluster on AWS that we saw. We define here what region the cluster should run in, what VPC to use, what subnets to use, and so on. With this, customers can then layer policies on top, such as to enforce that only certain VPCs may be used for GKE clusters. Now zooming out a bit, we've just briefly explored how GKE integrates with the native environment, specifically in the case of running on AWS. You may be wondering how we provide a unified operational experience on top of such a large variety of cluster deployment environments. That journey starts with a unified authentication experience. Many customers have standardized on a few top identity providers for their corporate authentication needs, such as Microsoft Active Directory, Okta, and others. GKE clusters support OIDC, OpenID Connect, so that customers can authenticate using the same familiar corporate credentials to all of their clusters across all of their deployment environments, instead of using GCP accounts for some clusters, AWS accounts for other clusters, and so on. Let's see how this works. Here, I've registered my GKE on AWS cluster, but I haven't yet authenticated to it. Let's click the login button. In this case, we're using Okta as our example corporate identity provider. So I'll enter in my Okta credentials here. And now I'm logged in. The process is similar on the command line and also works the same way for other Anthos clusters. After authentication, I can now use this web console to see information about the cluster. I can see the nodes that make up the cluster and information about each node, such as the pods running on that node. Now, so far, we've explored running GKE on AWS. That's one option for running your workloads. You can also run GKE on other clouds or in your own data center. You can attach your own existing EKS or AKS cluster to Anthos, and you'll soon be able to bring VMs to Anthos as well. For example, the second cluster I have here in the web console is an AWS EKS cluster that's been registered to my Anthos environ, an administrative domain for Anthos resources. Once registered, you can run the same higher-level Anthos services on top, such as configuration and policy management, as well as service management. With this option, customers can keep using their existing Kubernetes distribution and can more easily onboard onto Anthos while relying on Google to test and support the integrated solution. AWS EKS and Azure AKS are supported today, and more distributions will be supported in the future. Now, if and when you'd like to move to GKE, you'll get many additional benefits. You'll get a Kubernetes distribution backed by the company that created Kubernetes and with the most experience in managing it. It'll be the same Kubernetes distribution everywhere with the same networking and identity stack, many of the same security features, and so on. And you'll get a more consistent experience for managing the cluster and its lifecycle. Now, switching gears, we've just seen how Anthos provides a consistent management experience to access all of my clusters across deployment environments. Beyond access, many customers also need a way to ensure that their policies and configuration can be applied across all clusters reliably and uniformly. And this is where ACM, Anthos Configuration Management, comes in. With ACM, you can have all of your cluster configuration policies defined in a central Git repository, and that will be synchronized and applied across all of your Anthos clusters. This gives you a way to easily manage a fleet of clusters and prevent drift with continuous monitoring. Using Git as the source of truth, you can manage your configuration policies as code with the power of source control. So you can integrate code review flows, be able to easily audit changes, and you can easily revert back to previous versions. Many of our customers use ACM to apply and enforce policies like limiting host OS access, as well as limiting container repo access, and shutting off external ingress. For this demo, I've configured all 4 of my clusters to pull their configuration and policies from the same Git repo. They're all pulling from the same Git branch, and they've all updated to the latest commit. Clicking into one of them, the Git repo URL is configured here, and the subdirectory we're using is configured here. If I navigate to this Git repo, and then the subdirectory, I can see the configuration and policies that are being applied. Specifically, in this cluster directory, I have the cluster-wide configuration and policies. For example, we have a policy here that requires that all namespaces have a cost center label for auditing purposes. Going back, there's also a namespaces directory that defines a few namespaces that will be managed by ACM. For example, in this file, we create a shipping dev namespace with a cost center label. Switching back to the terminal. We see that the shipping dev namespace has been created by ACM. Let's see what happens if we try to delete that namespace. We see that the namespace was deleted and then immediately recreated by ACM about 3 seconds ago. So ACM is constantly monitoring to make sure that what's deployed matches the source of truth in your Git repo. Now, what if we were to try to do something that violates our policies? We saw earlier that there's a policy requiring that all namespaces have a cost center label. If we try to create a namespace that doesn't have such a label, this action is denied and the namespace does not get created. With our cluster configuration and policies in place, the next thing we might want to set up is our CI/CD pipeline. For this, one simple option is to use Google Cloud Build, our fully managed serverless CI/CD platform. With Google Cloud Build, you can easily define pipelines consisting of arbitrary build steps run as container images. They can be automatically triggered from your source code repository and run on Google's infrastructure. For this demo, I've set up a really simple pipeline here that performs 3 steps. First, we do a git clone of the Kubernetes examples repo. Then we update the service definition to use a service of type load balancer instead of node port. And finally, we configure kubectl and use it to deploy the guestbook sample app. Now let's kick off the deployment. While that's running, let's view the progress in the web console. Here, we can see the 3 steps and the output from each step. Notice that we deployed this app to our Anthos GKE on AWS cluster. So while your CI/CD pipeline can be running on Google Cloud, you can use it to deploy to any Anthos cluster, including clusters on-prem and in other clouds. In this case, our cluster is actually sitting in a private VPC in AWS. We're able to access it because there's an agent running in that cluster that reaches outbound to Google Cloud to maintain a persistent connection. We didn't need to open up any firewalls or expose any public IP addresses for that cluster. This ability to proxy Kubernetes control plane traffic is currently in alpha. So this pipeline is pretty simple, and it finished quickly. You can, of course, include many more steps, such as steps that build container images, run validation and unit tests, and so on, all within this fully managed service. Let's now move to the Kubernetes page in the web console. We can select the cluster to view, and we see here that our guestbook workload has been deployed. In addition, our guestbook service is also running, and an AWS ELB, Elastic Load Balancer, has been allocated. We can click into that view the guestbook, which is currently empty, and add an entry to it. With this cloud build integration, you can build your app once using our serverless CI/CD platform and deploy it across multiple clouds. For customers that need to build jobs to be able to access private resources or need more configurability, we're also offering a new feature called Custom Worker Pools, currently in limited beta, where you can run builds in your private network on GCP using VPC network peering. Now, after we've deployed our apps, one more thing we might want to do is to be able to monitor them. Anthos makes this easy with ASM, Anthos Service Mesh, which is our managed version of the open source Istio project. With ASM, service operators can gain more visibility and control over your services, including traffic management, authentication and authorization, monitoring, and alerting. For this demo, I deployed a sample online boutique app a few days ago on my 2 GKE clusters on GCP. With the ASM UI, we can see at a glance how all of our services are doing. We can also drop into a topology view to see how the services communicate with each other. From here, we can drill into each service to get more information about that service. We can see any SLOs we set for the service, as well as a lot of metrics for the service, such as requests per second, error rate, latency, request size, and so on. As of the latest release, GKE clusters on GCP can be part of the same service mesh, so they can load balance between them, and we can aggregate the metrics for the services running on them. So the metrics we see here are aggregated from both of our GKE clusters that are on GCP. If we want, we can also break this down by cluster to monitor each cluster separately. For example, let's do that for this latency graph here. With this view, we can see how the services in each cluster perform relative to each other. The red line represents one cluster, and the blue line represents the other. Taken together, these monitoring and multi-cluster capabilities make ASM a great tool for operating your services. Note, though, that these capabilities are currently only available for GKE clusters on GCP and will be coming soon to Anthos clusters running on-prem and on other clouds. To wrap up, we just saw in the demo today how we can bring workloads running on other clouds to Anthos, whether you choose to use GKE or another Kubernetes distribution. We saw a unified authentication and management experience from the web console. We applied the same configuration policies to all of our clusters. We deployed an app to a GKE cluster on AWS using Google Cloud Build. And we saw how we can use Anthos Service Mesh to monitor the services running in our clusters. There's a lot more we didn't have a chance to cover today. So check out the other sessions this week, as well as our website at cloud.google.com/Anthos. Thanks for watching, and stay safe.